Wasabi, you guys. Welcome to Integration Bee Training for Advanced. In this section, we'll be doing inversion manipulation, but it'll be the trickier stuff. Some very, very tricky manipulations that we can do with the inversion technique. So we have this integral, and I see some suspicious, well, the balance look a little weird, right? We have root 2 minus 1, root 2 plus 1. However, we have x plus 1 over x here. Well, I know that whenever I do u equals 1 over x, this will neutralize the derivative, because we've seen that happen a lot. So let's just go ahead and try letting u equal 1 over x. Now, the cool thing is, whenever we have root 2 plus 1, well, actually, let me write it this way. Let me write it this way. I think this is a lot easier to see. So this is equal to 1, right? Because, you know, square minus a square, we get 2 minus 1, which equals to 1. And so because of this, they are reciprocal to each other. Okay? They are reciprocal to each other. And so because of that, when we do u equals 1 over x, the bounds would actually not change. And so we would still have root 2 minus 1 and root 2 plus 1. Okay? And now, with a little easy stuff, right? X squared times 1 over x. This gets neutralized. And then here, nothing changes here because of commutative property. And then the only difference is now we have negative ln of x. That's the only difference we have, right? And of course, whenever we have like an exponential function like this, we do algebraic manipulation. It's just like ninja substitution. So we can already see, you know, if we multiply top and bottom by x plus 1 over x to the power of ln of x, right? When we add these two together, it's just going to cancel out. We've seen this so many times. So we go ahead, and this should give us 1 over x. Right? We're just going to jump into the answer because we know this is going to cancel out. And so now we have a half ln of x from root 2 plus 1 and root 2 minus 1. Now, this is actually equal to the ln of root 2 plus 1 minus root 2 minus 1. We already know the reciprocal of this, right? This is equal to ln of root 2 plus 1. Because the square, by log rule, the square comes out and cancels this out. And so this is our answer. So just be aware that, you know, some suspicious bounds can reciprocate as well. So we have this integral here. This integral is from Stanford Math Tournament Integration Bee, and it's a little tricky. It looks a little intimidating. Like it looks like a mess. Bunch of logarithms and then some random x squared plus 1 here. And I think a lot of what people would mistake to do is probably let x, or like do a trig sub with like x equals tangent theta. And I think it just made it a little uglier, I believe. So, but suspiciously, we have a bunch of x and then 1 over x, a bunch of ln's. We have this here that could be neutralized when we perform the inversion. So let's go ahead and try u equals 1 over x. Okay. Then we end up getting ln of 1 over x ln of x here, it's 1. And then we have x squared plus 1, because we know that neutralizes the RDU. And then we have ln of 1 over x plus 1, and that's the only difference we have. Okay, so what now? What do we do now? So, it looks like this doesn't lead us to anywhere, but let me first label this as A and B. And note that A plus B is equal to 0, right? Because ln of x plus ln of 1 over x does indeed equal to 0. Okay, now let's go ahead, and if we add these two together, we get, well, let's see, the numerator. We can actually factor out the numerator, right? This is like AB plus 1 all over x squared plus 1. And then on this side we have 1 over a plus 1 plus 1 over b plus 1. Okay, if we simplify this, we get something like a plus 1, b plus 1. And then here we get a plus b plus 2. And we know that this is 0, so we just have 2 on top. Here, this is ab plus a plus b, which is 0, plus 2. Oh, I'm sorry, plus 1. Plus 1. Okay, so this is 0, because a plus b is 0. Aha, so we have a plus b plus 1. So what we have is ab plus 1, x squared plus 1. We have 2 ab plus 1, and they cancel out. Very nice. This actually cancels out too. So it seems that we only have just inverse tangent. And so our answer is just pi over 2. And that's it. Okay? Dummyfy your functions. It's very, very helpful, very clean, and definitely gets you to the answer very quickly. So this is the trickiest one. This is our last integral, and it's the most difficult one. So this integral is from Gmain, and holy hell, this integral is a killer. It is a huge killer. So there's a lot that we have to do to solve this integral. So just follow along very, very carefully. So first thing is we're going to do a force substitution. So what that means is I'm going to let u equal the square root of 2 to the power of x minus 1. Okay. And what this would give me, u squared plus 1 equal to 2 to the power of x. Okay. And then 2u du is going to equal to 2x ln of 2. However, that 2x, we know that this is u squared plus 1 ln of 2 dx. Okay? So let's go ahead and write that all out. Okay? Patience, because we are juggling with a lot of things. All right? So you have to be very careful speed integrating everything. Okay? What is x, first of all? X is the ln of u squared plus 1. If I do that, I get, over ln of 2 equal x. Right? So, okay. So that's technically what I have here as x. And so I'm going to have to follow that We could write log 2 u squared plus 1 minus 1. Okay, let u, this is u, ln of 2x minus 1 is u squared. Okay, now everything for dx, this is 2u du with ln of 2 u squared plus 1. Okay, that was a lot. It is a lot. It'll just, you just kind of have to be very careful. So this cancels out. Okay, let's go ahead, kind of simplify this a lot further. So we have ln of 2, and I have ln of 2 here. Let's go ahead and factor those two out. Ln squared of 2, and now we have ln of u squared plus 1 minus, remember that we have log base 2, so this would equal ln of 2 over ln of 2, which is why we have ln of 2 here. Okay, we have this 2, don't forget that 2. Okay, we're going a little slow because, trust me, you do not want to make a mistake and then continue forward and then try finding your mistake, because it's very bad. Okay, let's see. Oh, look at this. We have 2 ln of u times u squared plus 1. So I see this cancels out. Okay, we're just going a little slow. I know it's a little slow, but you gotta have some patience. Okay. Alright, so now we're left off with 1 over ln squared of 2. We have ln of u squared plus 1 minus ln of 2. U squared plus 1 times ln of u. Okay, you should have at this form. Okay, nothing else. Nothing else. Okay. Now that we have this integral here, this is very hard to see, but we're gonna let u equal 1 over x. We're gonna let u equal 1 over x. Okay, I know I dropped the bounds, but you can always bring it back. 0 to infinity. Okay, and now we have ln of 1 over u squared plus 1. That's ln of 2. We have ln of 1 over u. And this gets neutralized. Right. Okay. So we're here now. Then, when we simplify everything, let's see, we get a negative because of this. And we have, let's see, this is u squared over u squared. So we have ln u squared plus 1 minus ln of u squared. Okay. And then this is also minus ln of 2. Ln of u squared plus 1. Okay, so now look what we have here. So what we have here is, this is I. Here we have, let's see, ln of u squared. I'm sorry. This, we start with this. This is I. We start with this. Let me actually go like that. So we start with I. We're looking at this here. We're comparing it to this here. Here we have ln of u squared, right? Ln of u squared minus ln of 2. So we have minus I, and then plus, don't forget this, And then this is technically plus 2 ln of u, which cancels out this ln of u. Aha! So what we have is this 2y. That's going to cancel out the 2. So we get ln of square 2 here. Right. And then from 0 to infinity. And then we are left off with du u squared plus 1. So it seems that our answer is pi over 2 ln square of 2. Holy hell. Oof. Yeah, I cannot do this fast. I will easily mess up if I go too fast. So I had to take it very slow and make sure that I don't, mess up on some constant or something. Okay, so definitely practice this integral, because this is actually you'd be very surprised how much this shows up in advanced integration bees. So, but yeah, this should be your answer. And yeah, that's about it. That's all the tricky manipulations that you can do with inversions. Okay, I hope this video is helpful, and yeah, thank you so much for watching. I'll see you guys in the next part.